Okie dokie. So, oh, no, not that course. So we finished the constants, right? For next class. We finished talking about constants, right? Yeah. And the whole point of them was, okay, statements and expressions. Cool. Yeah, constants was a great way to give some important value a name. And it also is a great way to just, if that important value needs to get updated and it's used a lot, all you have to do is actually change it in one spot and it changes it everywhere. So that's good. So don't need this. Collab. Reconnect. Okay, let's clear all this out. Okay, last chance. Any last questions before we get going? All right. So expressions. There's expressions and statements. All expressions are statements, but some statements aren't expressions. So, for example, something like print hello world, that's a statement. Something like some variable equals 5, well, that's an expression. There's some number crunching. I mean, not really, because it's just the literal 5 being assigned to some variable. But it is an expression. There's something going on. But maybe more explicitly is this example right there. Some other variable is equal to some variable plus 1 times 2. Now, one thing I want to point out here is in programming, in Python, if you want it, like, you know how like in math, right, if I had like 7 times x plus 1, right, well, that would mean multiply 7 by the x plus 1, right? In Python, it's too stupid. You would have to add the star to say 7 times. Be aware of that. A lot of students in lab are getting mixed up with that one. It's an easy mistake to make. But this is a more explicit example of an expression, right? Something is getting calculated on the right. Some computation is happening. And something's getting evaluated to a number, and then finally that value gets assigned to the thing on the left. Remember, with assignments, the thing on the right is all done first, and the last thing that'll happen is the value actually gets assigned to the thing on the left. Where I'm putting it needs to be on the left-hand side. That's important. We saw that in activity last time, where what happens if you try to assign, like if you flip the order, like what if you wrote 5 equals a? It's not going to work. It's going to complain and say something like, you can't assign a value or update the value of a literal. Because it's thinking you're trying to put the value of a into the literal 5. It's like, I can't do that. That's not a thing. Operators. Plus, minus, multiplication, divide. These are operators. And then operands are the things that the operators are acting on. So 1 plus 1, or let's say 1 plus 2, the operator is plus. The operands are the 1 and the 2. We already did this, I believe. Now here's the tougher one. So here's an exercise. Here's what I want you to do. I'm going to give you, let's say, 3 minutes to work on this. I want you to write some code and try to make use of variables and whatnot. But I want you to write the code to convert a value, a temperature value, from Celsius to Fahrenheit. That's what I want you to do. Write the code to do that. And I give you a quick little, I do you a favor here. If what you're thinking is, I don't know how to convert Celsius to Fahrenheit, well, that's okay. I've saved you typing it into Google. You can just go to any of these websites and it'll tell you how to do it. So have at it. See if you can get that figured out. Raise your hand if you're done. Raise your hand if you'll be done in like 25 more seconds. Okay, keep at it. All right, I've got a working solution right here. Now, raise your hand if what you have is more or less exactly what I have. Well, good. Raise your hand if you've got something a little different, actually. What did you do?
Converted to Celsius. I put input for Celsius.
Ah, I see.
To an integer.
Cool. That's even better, right? Because then it's like an interactive program. You can modify it. Whenever I want to change the calculation, I actually have to change the code. Where you didn't, you just rerun and enter it. That's good. Did anyone do anything else a little different? So yeah, this is good. This will work. But of course, like I've always said, now this is perhaps the most complex piece of code we've written now. And it's not just about writing code, it's about writing correct code. So, I mean, I looked up the formula, I looked up the expression, and I'm confident it's right. But it's always important to test it. So, there are a couple of things I know. A couple like anchor points. I know 0 degrees Celsius is 32 Fahrenheit. So when I run it and I see 32, okay, that's good. That's a good sign. It doesn't mean it's right, but it doesn't mean that the code is right, but that answer was right. And I also know negative 40 is the same. Negative 40, negative 40. So that's pretty good. I've got these like 2 data points where I've confirmed its correctness. Maybe it's a good idea to do one more. What's 50 degrees? Let's just do a quick test. 10 C2F. 50 degrees, yeah. So I'm pretty confident my code is correct. But never, ever, 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 ever write some code, hit run, and be like, okay, it's good. No. You write code, you hit run, you hit run, you hit run, and you verify it's correct. And then you move on. You always want to test your code to make sure it's actually doing what it's supposed to do. And it's important to test your code along the way. Imagine writing 50 lines of code, but you made a mistake on line 6. That mistake is going to compound the whole way down. It's going to be easier if you find those mistakes as you go. Way easier to find the mistakes and way easier to correct the mistakes as you find them as you go. So always be testing what it's doing very frequently. Okay, operators on other types. So the operators for values other than just numerators, we'll see many of these as we move through the course. We already saw this one, right? What happens when you add strings together? It concatenates. It's a fancy way to say it puts them together. Let's just do that real quick. It stuck them together. If you wanted there to be a space, I don't know, you could just add a space to one of the words. You could also say hello plus the string that's only a space plus the string world. You do that. And you could also use the multiplication operator. Without counting, who can guess what it did? We may have already talked about this. It just repeated that string 10 times. Yeah. And we can get fancy. Let's see what happens if we do world plus, right? It's going to go like that. Cool. There is an order of operations. It's going to follow what you're used to, but when in doubt, you can add your parentheses to kind of, make sure it's working the way you want it to. Okay, large series of statements. Everything we've done so far has been little pieces of code, right? Maybe 1, 2 lines of code. Maybe I've done a couple more lines of code just for demonstrating stuff. But typically when you're writing code and you're writing software to solve problems, you're going to need many lines of code. And those we put into, those are called scripts with Python. We call them scripts. Languages like this, we call them scripts. Other languages, we might use a little bit of a different word. But we call them scripts. Now, fortunately, when we're coding in Colab, it's all there, right? If I really want, I can file download. I can download the .py file. That would be the script for it. You can download the IPYNB. That means like the notebook file. That's so you could upload it into Colab and it would look just like this. It's got a couple extra bells and whistles attached to it. But these are our scripts. This is where we're writing our code. These cells can get as long as we want. We can hit run. And we can have as many cells as we want here, and we hit run. But of course, when I hit run on one cell, it only runs that one cell. Okay? And an important thing to note is if I have, here's something funny. If I say A equals 5, and then I go down to another cell, and I say print A plus 1, and I hit run, it's going to be mad. It's going to say, what the hell's A? Who knows what I did wrong? Well, yeah, it is. I made it in, it's a variable, storing. Ah, gotcha. You thought it was the string A? Yeah. Easy mistake to make. What's wrong here? What did I do wrong? I didn't actually run the code that said A equals 5. So be aware of that. That could happen. If you're like, I'm looking at it right there, but it's saying it doesn't exist, maybe you didn't run that cell. Try giving it another run and see what happens. All right. Yeah, they're called scripts. Python will run each, so you got a whole script. It might have 100 lines of code, but Python will only ever run one line at a time in the order that it goes. Starting at the top, going to the bottom. Now, it might jump around a little bit, and we'll talk about that. But that's just it, one line at a time. So when you see statements like A equals 5, A equals A times 2, it's fine because it does the first line, then it does the next line, and so on and so on and so on. So it's all fine. You can write scripts in any text editor that you want and run it with any Python interpreter that you want, but we're using Colab for ease, and not just ease, but because it's awesome and it's free, so hey. But there's a lot of other options out there. You can use Colab, that's the one we're using. You could use something simple like Notepad, Sublime, that's another text editor, PyCharm, VS Code. These are all just places where we can write code. But really, something as simple as just if you go to your computer and open up Notepad, assuming you're on a Windows, you could type code in there and run it. It's fine. All that really matters is that you have the program that can take that text and run it. It doesn't really matter where you put the text. You could write it in like a Microsoft Word document if you want. Don't. But you could, but don't. You don't want all the fancy stylized stuff there. All right. Now, we'll skip this activity because it was already done in the lab, but what I was going to say was take the sentence, I am taking CSCI 161, write a program that stores each word in its own variable and then prints the whole sentence to the screen using only a single print. So I'll just do it real quick. I'm going to be really lazy and copy. A equals, okay. right? And we already know how to concatenate strings. You add them together. So I'll just do it all in one line here. A plus B plus C plus D plus E. And I run and I see that. But of course, I don't have those spaces, right? Maybe I don't care. Maybe I'm fine with that. But if I wanted those spaces, there's a couple things I could do. I could go and add the spaces to the beginning of each of these things, like I showed you a moment ago, and it's happy. Or I can go and explicitly add space strings like this, and it would also work. Any questions? Nothing, really. That means everyone understands everything 100% so far. Is that right? I'm seeing nods. Okay, that's wonderful. All right, cool. Next topic, input and changing types. Well, if you had lab already, you've done this. So this should just be review. If not, well, you're going to be super prepped for the lab today. If you have, who has lab today? All right, you're going to be in great shape. So we know how to get information out of the computer, print. There's some value stored in the computer. Show me what it is. Print it out. Well, there's a way to get information into the computer with another function called input. I'm going to take this code here, copy. I'm going to hit run. It's a very simple two-line program. The first line was, using the input function, get information from the user, me. So I entered the word howdy. And then after that, I immediately printed it out. Something to note here, whatever I put in the parentheses will be a part of the prompt. See, if I change it to just give me, it just says give me. Hi, hi. Right? Now, big warning, and for those of you that already had lab, you know this. It's nice to add that prompt, but when working on Caddis, which again, if you have lab today, you'll learn all about that very, very soon. You don't want to have a prompt in there. You just never add a prompt when working with Caddis. Hi, hi. So let's take a moment and really see what's happening here. I know it's a simple two-line program, but let's talk about it. Input, it's a function that waits for someone to enter information. They type it in, they hit enter, and it's happy. Where do we store that value? Well, I'm getting whatever is inputted gets stored in the variable my inputted value. Then immediately after, I print that value back out to the person. And you might be saying, why are there two highs though? You said only print it once. Why are there two highs? Well, the first high was actually me writing it. Right? So it'll look like there's two, but really it only printed out one. The one was what I wrote, not what the computer wrote. The second one was what the computer actually outputted. And notice that I don't need to change the code. This goes to what you set up there using input for the Celsius Fahrenheit converter, right? With Celsius Fahrenheit, if I wanted to change the value I'm calculating, I needed to change my code. Where you didn't. Your code stayed the same, you just hit run again and entered a different value, which is kind of nice. So it's not dependent on some hard-coded value that I put in. It's dependent on whatever someone who's using it inputs, which is nice. So here, I don't need to change the code for it to output something different. Because it all just depends on what I'm inputting at runtime. So this is a runtime thing, where the code changes happen before I hit run, which is fine. It's just be aware of the difference, of course. And finally, here's another big thing, and we talk about this in lab, but I'll say it again here. Finally, no matter what you input, no matter what, I'm going to hit run. 11. No matter what I input, it always reads it as a string. And you're going, but it's 11. It's the string 11. Always as a string, always. Then that begs the question, well, what if I want it to be an integer? Well, just wait, you'll see. And you might already know. Okay, Okay, I just did this activity already, I spoiled it. I'm ruining all the fun today, I'm sorry. So the type of the inputted data, like I just said, no matter what you enter, it's going to be a string. But Python gives you a nice and easy way to convert values from like a string to an integer. Oh, what did I do wrong? Am I missing a parenthesis? Yeah. 55. So first, I read in the string 55. So the string 55 is stored in the variable my value as string. And then on the next line, I said, okay, take the value, my value as string, and convert it to an int. And how did I do it? Well, I just said int and wrapped it in the parentheses, the value that I wanted to convert. And then that converts it to an integer and puts it into my value as int. Great. Now line 3, well, that's the line that actually prints something out. And I print out my value as string, and I print out its type immediately after. By the way, if you didn't know, you can add parentheses to your print functions, and it'll just keep adding new things to the same line. That's what I did there. That's why you see 55 class stir. So we see 55 printed out, and it tells us that its class is string. Then on the next line, I say, well, print out my value as int, and print out the type of that. And we see, well, 55. It looks the same, but it is a different type. It has the type integer. This is important because, let me show you a quick example. Let's just do like A equals input, B equals input, print A plus B. I'm going to hit run. I want to produce the sum of these two values, right? So I'm going to enter 1 and 1. So when I hit enter, I want to see 2. But of course I see 11, which makes perfect sense, because what did I do? I concatenated two strings. It's like I already said in lab. It's like, remember being little, like, what's 1 plus 1? 2. No, it's 11. That's what Python just did to you. It's trying to, I don't know, be clever. But it's because it did exactly what you asked. Take the string 1 and concatenate it with the string 1, and it looks like 11. But it's not the integer 11, it's the string 11. If I wanted it to actually be int, I could just wrap it immediately. I could wrap the input in int if I want, or I could have done it, oops, 1, 1, now I get 2. So I read the input, immediately converted it to an integer, and stored it into A. Or if I want to I could do it a little different. B, I could convert it to int here. That'll also work, except so here, it was different from before. Before, I read the input, immediately turned it to an integer, and stored it in a variable. Here, what I'm doing is I read the input, stored it into a variable, but it's a string. But then, when I wanted to do the sum, is I converted A to an integer, converted B to an integer, then did the sum, and then printed it out. It just, the order, or the timing of when each thing happened was a little different, but it doesn't matter. Result was the same. Functionally, it was the same. Yeah, there we go. Any questions about that? Yes?
If you were to just say you were to convert an integer into an integer, would that be fine still, or would that?
It would, yeah, it would. Here, let's do it. We'll do it with input too. A equals input, print a type of a equals int of a, print a type of a, and then a equals int of a again. This is kind of what you mean, right? Doing it twice. 5. You just converted an int to an int, and Python's like, okay, fine. I can convert it to a float and then an int. 1. See? It's a little different. What do you think is going to happen if I do this? Convert the string hello to a float. Python's going to go, I can't do that. That's not a thing. And if you're thinking, oh man, why not? Well, then let me ask you. Convert the string hello to a decimal number. And you go, well, I don't know. That's what Python just said. It's not that it won't, it's just that it doesn't know, like, what does that even mean? That's a kind of a nonsense statement. So it's not doing it. Other question, that was a good question. Any other questions? So in other words, with this particular example, obviously, converting something to an int will only work if the thing you're trying to convert to an int is an int. Or can be. A float can be converted to an int. Let's see what happens if I enter 1.5. Well, the string 1.5 gets converted to the float 1.5, which got converted to the int 1. When this happens, whenever you convert a float to an integer, it doesn't round. It'll never round for you. Let me prove it. And hopefully Python didn't update recently such that they'd finally change this. Yeah. 1.9999999 as an int, it's just 1. Why? Well, what it does is what we call truncating. Effectively, it's always rounding down, but really what it says is just ignore all the decimals. So 1.9999999, it's 1. It's the same thing. I think I showed you what happens when you did interdivision 5 by 2, right? Did I show you guys that one? Yeah. Same thing. It just forgets about the decimal. No rounding, it just ignores it. I showed the other class the other day. What was it? I said 77 and b equals 123.456. Print a plus b. Yeah, that's a... I just saw your face go, what? No, that makes perfect sense, right? Raise your hand if you look at that and you're like, yep, checks out. Yeah, that's what I thought. So what's the problem? Who can tell me, right? What do you say? Where the hell did that 2 come from? Let's be more precise. Where did that 0.00000000000002 come from? It wasn't a 2. It was a lot smaller than that. Fair, yeah, fine, thanks. I mean, we all know 77 plus 123.456 is in fact 204.456000002, right? No, it's not. So we got a bit of an issue here, huh? Let's check. I'm going to show you another operator that we're going to learn soon. Yeah, false. This tells me if these things are equivalent. Equals equals tells me if it's true or false. Are they equal? And this is saying no. But we know that it's 200.456. So what's going on here? Now I'm going to talk about this in more detail a little bit later, but I figured I'd show you because I showed the other section and it's kind of interesting. Everything I'm about to say is really not going to matter for this course, to be very clear. But I'm going to explain an interesting phenomenon. Let's start by getting to the root of the issue. It's really not the computer's fault. The computer is acting in a way based on a limitation of reality, but we'll get there in a moment. Let me ask you, I need a volunteer. Someone raise up their hand. Trust me, it's going to be a really easy question. What comes after 1? 2, right? Yeah. Integers, right? What comes after 2? Someone yell it out. What comes after 1,000,000? What comes after 1 billion? What comes after a cajillion? Exactly, right? Cool. And we could keep going forever. We could do this all the way towards infinity. But I could count my way there. 1, 2, 3. And I do this forever, and I'll just keep going and going and going and going and going. But I can say like 1, 2, 3 along the way, right? So far, so good. This isn't, I mean, the integers, right? I know. You learned about these a while ago. You're probably fine with this. Now, forget integers for a second. Let's talk about real numbers. Numbers with decimals, right? Okay, what comes after 1? Yeah, we got a bit of an issue here, don't we? Who thinks 2 comes after 1? I mean, it does, but we miss some things. Is it 1.5? Well, we miss some things. 1.25? Well, we miss some things. 1.0001? Nah, we miss some things. 1.0000000001? We miss some things. I mean, we could keep going towards infinity with real numbers, but we also have this issue about, well, how many numbers are there between 1 and 2? There's a lot. So, I mean, with integers, I could put my finger on each integer as I went. With real numbers, I can't even do that. Here, this is the thing. There is actually, you know, we know of the idea of infinity, right? You know, it just goes on forever. But there's actually different types of infinity. The first one with integers is what we call countably infinite. You can count them. And then there's uncountably infinite things, where it's just like, you're screwed. You can't count them. So, this is the root of the issue. Who here has taken Stats 101 already? Okay, for those of you that have, raise your hand if you have, really high so I can see. If you've already taken it, not currently taking it, because I don't know if you've gone. Okay, I'm putting you on the spot. If I roll a 6-sided die, what is the probability, and you can use a fraction, because I would use a fraction. What's the probability of it rolling on a 3? 1 out of 6. Exactly, right. Easy peasy. If let's think. If I'm going to schedule the test on some arbitrary day of the week, what are the odds, and it could be any day of the week. It could be a Saturday, it could be a Sunday, I don't care. What are the odds it's going to be on a Sunday? 1 out of 7, assuming I've got an even chance of each, right? What are the odds of it raining exactly 1 millimeter today? There is a very specific answer to this. You don't remember? Come on, this is the most interesting thing of Stats 101. 0. You remembered. Who knows why it's 0? Think about it. It's going to rain exactly 1 millimeter today? Well, it's because it's continuous. It's because it didn't rain 1. It rained 1.00124 7172211421. Because it goes on forever. The odds of it being exactly is just, it's not happening. That's why you always specified a range with continuous values. And then you did the integration, you integrated under the curve, right, to calculate how much, really you just summed up how much, how big was that slice of the graph. It's the same issue. So we've got a continuous space, but the problem is, in my computer, I have a finite amount of resources to represent numbers. I do. Conventionally speaking, I mean, Python's a little different, but conventionally speaking, on your modern computer, I've got 64 bits to store integers happily, okay? And it's happy with that. There's a lot of asterisks involved, but conventionally speaking. That means I can only represent 2 to the power of 64. That many unique integers. That's still a lot, but the point is there is a finite number of them. So I'm going to lose the ability to go any further. It's the same for floating point numbers. But the problem is, there's a hell of a lot more floating point numbers than there are integers. So the computer kind of just cheats a little bit and doesn't actually represent it doesn't try to represent all possible floating point numbers. And so that's why you see these quirks of what we call floating point precision issues. That would be that. Yeah?
Why does it spit out a higher value?
It could have been a lower value. It was arbitrary. So now the question remains, and this right now, if you remember this, great. If you forget it, it's fine. This isn't going to bite you this course. But if you want to know if these two values are equivalent, I'm in trouble now, right? Because look, I hit run and I can see it. But imagine I've got this big complex program. It's got these sensors. It takes some readings and it does some calculations. And we end up with these floating point precision issues. But I'm expecting the sum to be 200.456. And I'm checking, hey, let's do A plus B equals 200.456. And just as a consequence of the computer, it's saying it's false, but really it was right. So I've got a problem. Clearly this is a big issue, but there's actually a hilariously simple solution to this. What we do is we go, okay, look, if I'm dealing with real numbers, I'm going to be dealing with like measurements and whatnot. And you remember learning like significant digits, right? Like, oh, you know, you can't get more precise than like the least precise measurement, right? So, you know, you remember significant digits, right? You raise your hand if you learned about that. Okay, cool. Most of you at least. It's the idea of saying like, you know, it's about like 3 kilometers. Here's an example of why significant digits is important. My house is 3 kilometers away from the annex. Okay? And my office door, okay, let me say that again. My house is, you know, it's about 3 kilometers away from the annex. And my office door is 22 meters away, 22 and a half meters away from the front door to the annex. Therefore, the conclusion is my office door is about what did I say? What did I even just say? 20? So 3 kilometers and 22 and a half meters away, right? Well, you know, that first one I said, I was like, you know, it's about 3 kilometers. That wasn't a very precise measurement. The second one was. And adding a precise measurement to an imprecise measurement, you're going to be unhappy if you're expecting the result to be as precise as the second measurement. Because the first one was kind of like, you know, 3 kilometers. That's the idea. So here's what you do. You set a threshold where you go, you know what? I just care if they're close enough. So you take the difference of those things. In fact, usually what you do is you take the absolute difference. And you check if that absolute difference is less than some threshold. Because in this particular example, based on my sensory measurements, I can't get any more precise than 0.0000 whatever. So you just take the absolute difference and check that it's smaller than some value you care about. So that's how we deal with this floating point precision. So don't worry, computer scientists aren't just willy-nilly forgetting about these floating point issues. Now we got tricks to deal with them. Any questions about that? It's really not that important for right now. I'm just showing you because it came up in the other section and I thought you might find it fun. Cool. Abs. Who here knows what absolute value is? So for those of you that don't, it just means if I have the number 7, the absolute value of 7 is 7. If I have the number -6, the absolute value of -6 is 6. It just basically means if it's positive, you leave it alone. If it's negative, you make it positive. That's absolute value. So the reason I wanted to do that was I didn't know if the floating point precision was going to be bigger or smaller, kind of going to your question, of the value I wanted, so the difference could have been negative or positive. So I just took the absolute difference and checked that it was smaller than some threshold. That's all. End of the day, not that important right now. Don't worry about it. You may have found that interesting, or maybe it just confused you. If it confused you, you can forget all about it. Raise your hand if you thought it was interesting, because I think it's kind of interesting. Yeah, right? There you go. Oops. Okay, changing types. Yeah, you can do that. You can change integers to strings. You can change floats to integers, integers to floats. We were just kind of playing around with that. Great. And because we're just definitely not going to have enough time for this last activity, this is where we'll start off. When tomorrow, do we have lecture tomorrow? I don't know. Yeah? All right. This is where we'll start off tomorrow, but I'm counting on y'all to remember because I won't. Any last questions? Now, remember, if you are stuck on anything, if you're working on a caddis problem, if you want to swing by and say hello, if you have a question about a topic or something you heard about online, come to office hours. And if you want to know what my office hours are, well, you go here. And the reason I'm going there is because I don't even remember when I made them. Every year I always had it at 10:30 to 11:30, but I changed it this year, so now I can never remember. Office hours, 12:30, Tuesday, 12:30 to 1:30. Basically right now. All right, I'll see you later.